Hi everybody, on this video we will find the zero of this polynomial. Usually we do not need to find zero using all of these steps, but we will do all of these steps just to review. Alright, first we'll use the rational zero theorem. This will list all the possible and of course rational zeros. So all the possible rational zeros will be in the form of the factors of a constant term over the factors of the leading coefficient. So I will write factors of negative 16 over the factor, any factors of 3. Now list them. Factor of 16 plus or minus 1, 2, 4, 8, and 16. Factor of 3 will be just 1 and 3. Right. And then we will take every factor of 16 divided by each of the factor of 3. So first, if we divide it by 3, if we divide by 1, we'll just have 1, 2, 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1. And then we'll have 1 over 3, 2 over 3, and so on. So now we divide by 3. We will have 1/3, 2 over 3, 4 over 3, 8 over 3, and 16 over 3. Those are the possible rational zeros. Right. Of course, one of these may work or none of them may work. Alright, next we use Descartes' rule of sign. This will tell us the number of positive zeros and negative zeros. So number of positive zeros and number of negative zeros. To do that, we just count how many times the coefficient change the sign. So I start with f of x. And I will just count from positive to negative, that is 1. Negative to positive, that is 2. Positive to negative, 3. So the sign change, there are 3 sign changes. So in that case, we'll say the number of positive 0 is going to be 3. But notice that in the Descartes rule of sign, either that number or less than by an even number. An even number will be 0, 2, 4, 6, 8 or so. So we just keep subtracting 2. If we subtract 2, we have a negative number. So we stop there. So the number of positive zeros either 3 or 1. Next we do the negative zeros. For negative 0, we'll have to do f of negative x. And we'll have 3 substitute negative x into x to the original polynomial minus 4 negative x squared plus 12 negative x minus 16, and we will have negative 3x cubed, negative 4x squared, negative 12x, and negative 16. As we see, all the signs are negative and there will be no sign change, so we say no negative 0. Because there are no sign changes, all of them are negative. Right, now we go back to the first one. If we have to guess the solution, we know that it's not going to be any negatives. So we just try these numbers. Try the 1, and then 2, and then 4, and then hopefully we find it sooner rather than later. Right, now the next part of the question we do need to test. So we're going to test for 1 and test for 2 into the original function. Instead of substitute 1 into x, we do it that way. I will use synthetic division. That's a nice way to evaluate the values of the function. F of 1, so I will divide by 1, or x minus 1. The coefficient 3, negative 4, 12, and negative 16. Right. Carried out 3. 1 times 3 is 3. Negative 4 minus plus 3 is minus 1. Multiply. And then add. Multiply. And then add. Now this is f of 1. The remainder is f of 1, which is not equal to 0. So we say x of 1 is not a 0. If this is equal to 0, then that is the 0. So we say x equal to 1 is not a 0. Right. We'll do the same thing for 2. Coefficient 3, negative 4, 12, and negative 16. Carry out 3. 2 times 3 is 6. Add will be 2. 2 times 2 is 4. Add give us 16. 2 times 16 is 32. And 32 minus 16, 16. And that is the values of f of 2. And that is not equal to 0. So 2 is not a 0. At this stage, if we go back to the first part of the question, we'll keep going on this list and then until we find an actual 0. But there's a nice theorem. When we have a negative and a positive, the values of f of 1 and f of 2 have opposite sign. So let me write this down. F of 1 and f of 2. 1 is negative, 1 is positive. They have opposite signs. By intermediate value theorem, there is a 0 between 1 and 2. We know that there is a 0 between 1 and 2. Now, if we have to choose from this list, probably we have to choose 4 over 3 because 4 over 3 is 1.3 something is between 1 and 2. So that will be a logical choice. Without this, we just keep going with this list and hopefully we find one. But now we know that there's one between 1 and 2, so 4 over 3 may work, may not work, but we still need to check. Right, so the next part of the question, choose a 0 from the possible rational zeros, and we choose 4 over 3 because that is a logical choice. It is between 1 and 2. Right, so now we divide by 4 over 3, or x minus 4 over 3, and the coefficient is still 3, negative 4, 12, and negative 16. Right, write down the 3. 3 times 4 third is 4. That cancels out. 0. 0 times anything is 0. 12. 12 times that will be 16 and will be 0. Right. Now, since the remaining is equal to 0, 4 third is a 0. Right. So of course we can also put 4 over 3 back into the original problem. We should get 0, but using the synthetic division, we actually not only we know 4 over 3 is a 0, we can also factor. This is the zero factor theorem. We say that if x equal to 4 third is a 0, then x minus 4 over 3 must be a factor, and the other factor must be this, will be 3x squared plus 12. So now we also have 1 zeros. We just need to find the zeros from here. And here we say using quadratic formula, but I think we don't need to do that. Just make that equal to 0 because we already solve for that, which is 4 over 3. Now we just need to solve for x. And that gives us 3x squared equal to negative 12, or x squared equal to negative 12, I mean negative 4. Taking the square root on both sides, and don't forget the plus or minus. The negative inside the square root, that is imaginary I. Square root of 4 is 2, so we just have plus or minus 2i. So that polynomial from the beginning we have 4 over 3 and plus or minus 2i. So the zeros 4 over 3, 2i, negative 2i. Right. We do not need to go over all of these steps to find the zeros for that polynomial. But if we go through all of this, there is the reason that we do each step. We might skip a few steps, but I think it's still nice to go over all of this. Thank you for watching.